Hello, myself is Professor H.K. Bangale from Department of First Year Engineering, SND College of Engineering and Research Center, EULA. So we are discussing basic electrical engineering. In that last unit, the topic is work, power and energy. So in the part 1, I welcome all of you. So today we'll discuss on work, power and energy. So very first we'll discuss on work. So what is work? So while most people feel that work is done when you work on a problem or do homework, physicists say work has only been done when a force is applied to an object and the object moves in the direction of the applied force. So the definition of work, W, can be given as the work is nothing but the force in the direction of displacement. So the work is equal to force into distance. So W is equal to FD, and the SI unit of the work is Newton meter, and that's equal to joule. So the figure below shows or illustrates the work being done. So here the one person, what he is doing, he is simply pushing this object. So the pushing force is applied on a box through a displacement. So the displacement of this box is happened there. Okay, certain distance this box is moved away, right? So it moves from a distance of D from this place to this place. So the work done equals to W is equal to force into displacement D. So the force is act on this box and acting in the direction of the displacement, and that gives you the work, that is the FD. So the dimensions of work are force, newtons times distance, that is in meter. So the product of the two, that is Newton meter, is called the joule. In honor of physicist James Prescott Joule. So joule represents a relatively modest amount of work. So you do a joule of work when you lift a medium-sized apple through a height of 1 meter. So that is nothing but your 1 joule. So it may come as a surprise that no work is done while holding a heavy object such as a suitcase. So if you have hold a suitcase in your hand, it is heavy. But is the work is being done by the suitcase itself? So by the definition, what is work? So because the suitcase doesn't move, no work is done. However, you become tired because your muscle cells are doing work holding the suitcase. So the work is done by your muscles, muscle. That's why you have hold the suitcase. So no work is done by the suitcase itself, but it is the work of your muscles. So work is easily calculated when the force and the displacement are in the same direction. So see here, one person is carrying his luggage, okay, and what is it? He is pulling his bag, right? He is pulling his bag, and whatever the work is done, okay, that work means he apply the force in the direction of the displacement. So the direction is same. So but how is work calculated? When the force is at an angle to the displacement, it is a certain angle with the displacement. Displacement in direction mein ho raha hai, or force is applied in a certain angle. Okay, it is angle made with the direction of the displacement, and it is theta. So the figure below shows a person pulling a suitcase at an angle of theta with respect to the direction of the motion. His direction of motion is like this, and he pulls the suitcase with an angle of theta. So the component of the force in the direction of the displacement is F cos theta. So this is the only component of the force that does work. So in case such as this, only the component of the force in the direction of the displacement does work. So notice in the previous figure that the component of the force in the direction of the displacement F cos theta. So therefore the work equals to F into displacement done, that is D cos theta. So the work is always force into distance into the cosine of the angle between force and the displacement. So the direction is very, very important. So the W is equal to FD cos of theta. Now here the work can be positive or it can be negative or it may be zero sometimes. Okay, so work, when the work is positive, if the force has a component in the direction of the motion. So if the work is positive when the force has a component in the direction of the motion. The direction of the motion is this, and in the same direction the force has its component. Okay, that's why it is a positive. That's why it is a positive work. Now work is zero if the force has no component in the direction of the motion. Now direction of motion is this. Force is applied in this direction, right angle to that. So there will be no work done. So work is zero in that case. Now third case, when work is negative, so that time the force has a component opposite to that of the direction of the motion. The direction of motion displacement either hai, force either hai, so it is negative displacement. So when more than one force acts on an object, the total work is the sum of the work done by each force separately. So for example, if F1 does work W1, then force F2 does work W2, then force F3 does work W3, and so on. The total work equals W total is equal to W1 plus W2 plus W3. So in this way, the total work can be sum of the three vectors, that is W1, W2, and W3. Thank you.